Hello everyone, welcome to this video where I'm going to present and demonstrate DV power solutions for turns ratio measurement. As DV power has variety of products specialized for turns ratio measurement, we divided them to two series, advanced and standard series, and today I'm going to talk about TRT Standard series and its device TRT33C. Now I'm going to present the hardware of device. As you can see, device comes in a plastic case. After opening it, on the top side of the case you can see a quick guide of device where there is an explanation of connections from device to the test object, information about cables, and a quick guide of how to operate device in a standalone mode. On the right hand side of the device you can see 8 terminals. 4 of them are dedicated for connection of cables for high voltage side, and 4 of them are there for connection of the cables to low voltage side. 3 of them represent connectors for A, B and C phases, and the 4th one, the black one, is for connection to the neutral point of transformer if the one is present. Emergency stop button is also there. The name is self-explanatory, only used in emergency situations. After pressing the emergency stop button, all the running tests would be terminated. On the left hand side, power supply cable should be connected, and close to that there is a switch button. Flash drive port enables the user to insert the USB drive and download the data recorded previously by instrument. Interface port enables the user to control the device from PC device and our DVTR software. Ground cable should be connected to this point. This part of the device, called TC control, enables the user to connect the TC control cable to this connector here, and the other side of the cable should be connected to tap changer control box, and therefore we enable the user to change the tap position of the transformer by pressing these arrows. LCD screen with 4 rows is also there, along with the keyboard, and by this part we can see the results and set up testing parameters. These diodes indicate that if the test is running. Built-in printer is optional feature, so user can print results when test is finished. This is our test object, a 3-phase transformer with a vector group YN0, and on top of the transformer there is a tap changer simulator which enables us to perform tests on up to 5 tap positions. Firstly, we connect grounding cable to this port, as already explained. We need to think about our safety and safety of our equipment first. We will connect high voltage cables. They are marked with red color close to the connector, and they are color coded with our panel connectors, so the red cable should go to the red panel connectors, and the same applies for the other cables. This is to avoid any misunderstanding. These nitric connectors are really easy to connect, and we perform that this way. For low voltage side cables there is a white label and the same colors are present, and we connect the cables the same way. We connect power supply cable to this port. TC control cable should be connected if we want to provide automatic measurement of turns ratio. After pressing 1, our device will be turned on. Our cables, as mentioned, are color-coded, so we follow the connections from the panel connectors. The red one is the phase A. The red color of these TTA clamps indicate that this clamp is intended for high voltage side, and we connect it to the phase A on the high voltage side. On low voltage side, we have a white label. Again, we follow color patterns and connect red one to phase A. Device is ready, it's running, and it's connected to the transformer. Now we have two solutions for testing. Whether we want to use device in a standalone mode or we want to control device using our PC software. We have to connect this simple cable to the PC device, and then we will enable it to control device using DVTR. We can run tests using our DVTR software, which is complementary with our device and its accessories. Once we start running our software, it will recognize if TRT device is connected to our PC device, and starting test with start new test button. As you can see, again, device is recognized, and we press start new test. First menu, it's about test object information, and it's not mandatory to fill in this data and this note. This is just for future reference, and if user wants to create a report later. We have option to go with turns ratio or magnetic balance test using our software. Firstly, we will perform turns ratio measurement. We need to insert data about test object, which is 3-phase transformer. We select if we want to perform sequential, simultaneous, or both tests, which we will perform now. Test voltage can be selected between these values. With some of other TRT devices from standard series, it can be selected up to 250 volts, but with TRT 33C, these are selectable test voltages, and for this transformer 8 volts should be enough. We will automatically select a vector group with device, and at the end we enter the nameplate of test object, which is like that. In a first tab position, turns ratio deviation limit, this is default value 0.5%. It's defined by standards, but for some reasons you can change it if you want. We select tab changer button, and we select that on the high voltage side there is on-load tab changer in this case, but other options are also available for different scenarios. OLTC, we have 5 tabs, and we will enter high voltage value for first and last tab. And since we connected tab changer control cable, we will press yes and perform this test using our DVTR software automatically. We can save this template for future reference. We can load some other template if we want, or simply press next and start the test. Firstly, we double check the data and start the test by pressing this button. Until vector group is detected. It's detected as YN0, and we want to continue with this setup. Results which are displayed are here. There is a memory location, vector group, nameplate ratio, test voltage, applied voltage, measured voltage, and information about excitation current, phase angle for each phase, deviation for every phase, and pass-fail assemble. So for every phase up to now, this transformer failed. Turns ratio is not according to standard. We will hide results grid. Once measurements are done, our software will notify us. Test is completed. We press OK. We can check results here. We can show results grid, and we have option to create report, save these results. We can save it to Excel file, and we can see our results graphically. Once we want to leave, our software will notify us that we can save these results, and we will press yes. It will open a folder. We can create a new one or save it wherever we want, and we will save it as turns ratio test 1. And we are back to home page. We can now perform magnetic balance test. For this test, we use the same setup. We can again automatically detect a vector group, and we can press start button. And we have our results. We can display high voltage side results or low voltage side results. And we can again save these results. If we don't do it, we will be noted by our software. We will save it as magnetic balance test results. And these are functionalities of our DVTR software with TRT 33C device. Device is running. We want to test in a standalone mode. So again, we can select test voltage. We will use the same one we used while using software. We press enter. We can select another test object. But we will continue with 3-phase transformer. Press enter. We will perform both tests. Press enter, and we will manually select the vector group. Vector group is YN 0, and we enter the nameplate, which is 180 to 25. We test the first tap. There is no taps on a low voltage side, and we press enter to continue. Memory location is shown. It's number 40, 50 Hertz. This is something device recognized from the grid configuration, and we press start to test. Turn ratio test is usually really quick, so we will have our results shortly. And here are our results. For this purpose, we will perform one more measurement, but firstly we need to change the tap position of our transformer. And position is changed. We are ready to press yes and confirm. So we need to change the nameplate for this position. It is 172 volts to 25 volts. It's the second tap position. Press enter to confirm. double check it and press start. And we have our results. When we press enter, again device asks us if we want to measure another tab. We will press no, confirm, and we are back to the home menu. So you can find your results by pressing set. You can find memory location, and if you are interested, you can print out the results. You can go to print test recordings, press enter. Thank you for watching this video. For more information about this and other DV Power products, please visit our website www.dv-power.com.